Hi, this is Fraser Nyasu. Let's talk lab number 3, dimensional analysis. You kind of talked about this in class already. It's sort of in chemistry or sciences, if we want to show how we converted things or calculated things, we want those who are looking at our work to be able to follow. Let me give you a simple example that's kind of routine and mundane. You take 243 cents and you convert it to dollars, and everybody knows it's $2.43. It's like, how did you do that? Well, I just know it. Anyway, so we will develop ways so that others who are looking at our work can actually follow and understand how we got from A to B. And basically it's showing the units, showing the constellation of units, so that units don't just appear or disappear, but they actually progressively cancel as you convert from one system of units to another. And it turns out that if you follow this and think this through and build on this, you'll be able to solve quite a lot of general chemistry problems by partly thinking of how the units work. All right, let's get into Slideshow here. Now skip that one. That's where we'll be after we've done all of 1210 or 1500. So let's go here. Units. When we make measurements, we must write units, and I want to emphasize that you must write units. Even if you think it's understood, it's important to write them. You weigh something and you write 812. No, write 0.812 grams. So units are important. I'll get myself a pen here. Pointer options, pen. All right. So let's start with the mundane things you've talked about in class. Convert 22 meters to inches. Well, how do you do that? First of all, you can think it through and say, I'm going to break it down meters to centimeters, because you either know that relationship or can look that up, and meters to centimeters to inches, again, we can look that up. So the two arrows here, meaning that the two relationships we're going to use, come up with. So you go with the first arrow and you write 1 meter is equal to 100 centimeters. And for the second one, 1 inch is equal to 2.54 centimeters. And you can look that up. This one, you can look that up, or it might be provided. And this one, you're supposed to be able to conceive, given what centi means, namely 100th. And then, of course, I wrote over these things, but I guess you can follow. So you take that 1 meter is equal to 100 centimeters, and you can either have 100 centimeters over 1 meter or 1 meter over 100 centimeters, and you use whichever one cancels. And this one, in this case, the meter goes down, the meters cancel, and then the next relationship, inches must go on top, so centimeters cancel, and you end up with 874 inches. You know how to do that. So this is more or less a review. So here is a multi-component problem. Take 155 kilograms per meters cubed and go to milligrams per liters cubed. And again, you gotta formulate your path, and your path depends on what you know or what you can look up. So for example, one might avoid this path here by just going from kilograms to milligrams directly, if you know what the relationship is. But it's better to break it down in steps that are digestible and ones that you kind of know already. So take that first one, kilograms to grams. I know what that relationship is, or I can look it up. Grams to milligrams, similarly, milligrams. Then I say, I'm done with milligrams. That's what is required here. Then for meters cubed, I can go meters cubed. Meters cubed to centimeters cubed, if I know what that relationship is, and centimeters cubed to milliliters, and then milliliters to liters. So again, many of these relationships are ones that you either directly know, can reason out, or can look up. Let's see here. And so here it is in this case. That first arrow is that one. Aha! 1,000 grams per kilogram. That second one, 1 milligram is 0.001 grams, or 1 gram is 1,000 milligrams, whichever way you formulate it is just fine. And here, point 0.01 0.01 cubed and meters cubed. This is good. I would write it, if I were doing this, it's a colleague who wrote this, I would write it as 0.01 meters and write it cubed outside. But anyway, it's the same. But the point is, you cube the number and you cube the unit as well. Okay. And then a centimeter cubed and the milliliter cubed are the same thing. And so you can do that. And then 1 milliliter is equal to 1,000 milliliter. 1 milliliter is equal to 0.001 liters, or 1 liter is equal to 1,000 milliliters, whichever one you might want to use. And then after I've done that, you can do the calculation. So somebody looking at this can very well look at what you did. And yes, the units cancel out nicely to give the desired units. So now let's deal with multiple units. In this case, centimeters cubed to inches cubed. The thing is to remember that centimeters cubed is equal to centimeters times centimeters times centimeters. So each one of those has got to be processed separately. So again, 1 inch is equal to 2.54 centimeters, and you do it 3 times. And then in that way, you generate the 2.54, and 2.54, and you can do the arithmetic certainly, but you want to make sure that you are converting each one of these as a single step. Another way to do this is, of course, to say 2.88 centimeters cubed, and then times inch over 2.54 centimeters, and then put the cubed outside. Either way, those generate the same thing. So, about the work that we're going to do today, we're going to work with these copper tubes. Unfortunately, they're not exactly straight. I don't like that. But anyway, we're going to measure, it's a tube, so we're going to measure the internal diameter and the external diameter. Our goal is to find the volume of the copper metal. External, internal. This part for external, that part for internal. And then we're going to measure the height of the tube as well. And from those, we can find the volume of the metal. So here's what you have in your lab notebook. At least appears something like that. First of all, you recognize that you're measuring the diameter. So you've got to find the radius. And once you find the radius, the formula for volume is pi r squared. So we're going to go find the external volume. So go pi r squared, so pi r external squared and h, and then minus pi r internal squared h. It's better to do it this way, not the other ways. I can factorize things, but I like it this way because then it's clear to everybody what's going on. Here's the important thing. Units. So don't just give me the numbers here. Pi is a number. RE, give me the number and give me the unit. RE, millimeters. And then you square. H, millimeters. And then you do the arithmetic and you end up with millimeters cubed. Again, this is about dimension analysis. Put the units every time. Otherwise, here, significant loss of points. So I want the unit there. I want the unit here. And similarly on the other one. And then once you do the arithmetic, you end up with millimeters cubed. And I will say, I know where this came from because I can see it in your work. All right, moving right on. And so if you have the mass and you have the volume, you can certainly calculate the grams per millimeter cubed. All right. And so that's pretty straightforward. And then we'll convert units here. We'll go from grams per millimeter cubed, which is what you'll have up here, to grams per centimeter cubed. Aha! So remember, this is the cube thing we're talking about. And I trust that you know that 1 centimeter is equal to 10 millimeters. You can actually look it up on the ruler. A lot of times people have it backwards. It's like, ooh, it's just like saying, right, $1 is 100 cents, and somebody says $1 is equal to 0.01 cents. It's like, ooh, have that backwards. But anyway, think about whether you have the big one correctly defining the small one. The big one must be equal to multiple or many small ones. So again, here the units must work. You have grams per millimeter, right, cubed. So you go times 10 millimeters, right, per centimeter, and then you what? Cube all of that. So again, it's about units. I'm not so much interested in you getting the right answer. I'm more interested in the process because that demonstrates understanding. Moving right on, my friends. So you have grams per centimeter cubed from the previous answer, and then we ask you to go, kilograms per meters cubed. So grams to kilograms, centimeters cubed to meters cubed. All right. So at the end of the day here you'll have some number that says kilograms per meters cubed. And then here, in your weighings, you'll have weighed some copper filing, some copper foil of some kind. In a beaker, find the mass of the beaker, find the mass of the beaker plus the filings, and then with that find the mass of the filings. And then with that you ask you to calculate the volume. And of course, you guys know if density is equal to mass over mass over volume, then volume is equal to mass over density. And again here, make the units sure. All the units must be there and converted appropriately. Okay, so you can get the right answer in meters cubed. One of the things, of course, you need to think about is that this mass is in grams, and so in order to get things to work properly, it has to change from grams to kilograms. Moving on, my friends. So that's part number one, and then I decided to do paper. So you measure dimensions of the paper in inches, the length and the width of the paper. Okay. And so that will be inches, and then that will be done in inches. So with that, you can find the area of the paper. That's easy because you originally measured in inches and inches, so I can figure that out. Then ask you to convert from inches to centimeters, from inches squared to centimeters squared. Certainly we can do that. And then, having measured the volume of the rim of the 500 papers, we can find the when you measure the height is in centimeters. So if you have the area here and the height you can certainly multiply that to find the volume. So when you find the volume here, you want to note that this is volume per 500 sheets. All right. Here are the masses of the individual papers. You weigh a beaker and then put in one paper, then put another one, and so on until you've made added 5 sheets. And from these, certainly you can find the masses So the first one here is what? Calculate the average of one sheet, the mass of one sheet of paper. So if you can find the mass of each sheet here via subtraction, then you can find the average. And the average is mass per sheet. Aha, write it that way. So here, if you're asked to find the mass of the rim of 500, you take your answer from the previous exercise, which is grams per sheet, and then multiply by, again, we're looking for units, 500 sheets. We are interested in units and proper cancellation of units. And then you work out all the others here. So again, simple lab, certainly doable in a short time. There aren't any at least for 1500, not any solutions to worry about. Whatever it is, anyway, that we put in the burette for 1210, that goes directly in the sink. After all, it's just water itself. And then after clean up after yourself, retain all the equipment in proper location. I do have a problem with things ending up, or data logger boxes ending up with not the right equipment. Some boxes without data loggers, without autopipeters. So again, there's a list of things that are supposed to go in the data logger box in your lab manual. Check that and make sure that everything goes in the proper location. It makes it easier for the students coming after you, and there are hundreds and hundreds coming after you. Again, this is a nice, simple, straightforward lab teaching the very important concept of dimension analysis. You understand this and all that we've done here, you'll certainly understand many of the problems and how to do them in 1210 and 1500. It's one of those safe labs, but all the same, we are required by rule to have goggles in the lab coat. Have fun.